My name is Ivan, and this is my project on adaptability, probability, and video games. So my research question was, to what extent does dynamic difficulty vary from set difficulty in video games in terms of the link, if any, between player enjoyment and performance? But first, I want to talk about how did I get to the research question. So in grade 11, I took AP Computer Science Principles, and for one of the tasks, I was supposed to create a project with its own functionality. So I decided to create a game, and this game inspired by Street Fighter and Mortal Kombat. It's a 2D platform fighting game, and it has multiplayer, so you would play with someone else on the keyboard beside you, and that was the project. However, I still wanted to find out how could I get a computer to play against a player so that it would just be single player. And that year as well, there was an increased public awareness of AI with the release of large language models like ChatGPT available to the public. People began to be more aware of artificial intelligence and its capabilities. So this brings me back to my research question of how can I implement artificial intelligence inside of a game so that it can create better results for player enjoyment and performance. And this has three topics, which dives into computer science and psychology of a person, and also mathematics, analyzing that data. And first, I need to define dynamic difficulty and set difficulty and what those actually mean. So dynamic difficulty adjustment, or DDA, is a game processing method by which the game analyzes the player's behavior and changes its parameters based on that behavior. From Costner, mentioned the flow channel, which is a channel by which when the player is playing a game, based on their skill level and the challenge of the game, there are channels by which the player flows through. If the game is too hard and the player's skill is too low, then the player becomes frustrated and they quit the game. But if the game is too easy and the skill level is high, then the game is boring and the player quits the game. So it's finding an ideal game between that balance so that the player can continuously flow through that flow channel. And also, there's real-time user engagement by Andre et al. Because DDA in real time continuously processes that data from the player and implements it into the game so it adjusts to that player behavior or strategies. So this is a flowchart of the difficulties that will be used in this experiment. So the difficulty adjustment categories will be in real time, and it will be automatic because we're continuously processing that player data. In terms of automatic, there are the two forms, which is dynamic difficulty adjustment and the static. Static is the same thing as set data in my research question, where it's hard-coded values like easy, medium, hard, and the player can choose based on the difficulty level that they want to play. Continuing on with dynamic difficulty adjustment, there's rule-based and data-driven, right? So we'll focus on data-driven because we're continuously processing that player data so that the game adapts to that. And within data-driven, there are many different models by which you can use. At first, I wanted to try with neural networks, but due to limitations and lack of understanding, I decided to switch gears and opt for a probabilistic model. So in summary, I will compare static difficulty with probabilistic models of dynamic difficulty adjustment. But what about current papers that are out there about these DDA probabilistic models and how it can be implemented in games? So in my paper, there many literatures that I use, but the two most important ones, I think, were modeling individual differences in game behavior using HMM by Bunyan et al. HMM, or Hidden Makala model, is a progressive model by which it conceals and analyzes hidden states, and using that, it analyzes the the player, the output of the player. And with HMM, it goes through these different algorithms as well, so that it produces a weighted sum by which the game can then make a decision to adjust its difficulty. And the results were that final prediction accuracies ranged from 60 to 70%, which is amazing, because if you can model these differences, like these different characteristics of someone, then up to 70% to 60%, like that's amazing. The second paper was Dynamic Difficulty Adjustment for Maximized Engagement in Digital Games by Xu et al. And in this model, it's a player progressive model using churn rates. So they used levels and trials as a method of player progression. The higher the level and the more trials that they went through to repeat to do that level is how the game adjusted to its difficulty. And then this was mapped using level, trial, and churn rate. So in the black is highlighted the first level, the third level, and the 10 level, and how the amount of trials that they went through differentiated the churn rates, which is the rate at which the player retries the game, or the level, and by that they can map out the difficulty of that game, of the game. And this resulted in up to a 70% increase in core engagement metrics of the player. This meant that over longer periods of time of playing the game would save that data, and the player would become more engaged, and as it was adapted to their preferences. And these two papers analyzed games in long-term scale, and also in the transitions of levels and trials by which the player went through. However, I wanted to see like the gap. What if like there's limited player data and there's less time, and how can we try to transition and find and adjust that difficulty so it's better for the player? So this led me to my methodology, which was a mixed qualitative quantitative experiment. So to conduct trials, I have to collect two types of data: the quantitative, which is the game data, and the qualitative, which is the player's response of the game. That's the data. And using those two, I connect and I try to find a correlation between those two sets of data. So in terms of the build of the game, first I had to build the game, and it's a 2D platform fighting game, and there's a 90-second timer, and players would have to fight the enemy, and based on the timer, if the timer ended and whoever had the lowest health would lose, and if you ran out of health first, then you would also lose. And you would play this on a computer with a keyboard. So that's the game. And then there are two modes that I wanted to produce. One was the static difficulty one. So the players were given the option, the participants were given the option of easy, medium, and hard. And this is pseudocode for the procedure. And basically, if whatever mode they chose was a hard set value by which the movement of the enemy would be predetermined based on random direction facts. based on that mode that you would choose, the enemy would track the player faster and easier. And for the second one, which is dynamic difficulty build, so this would also mean easy, medium, hard from the player's perspective, from the participant's perspective, but it didn't really matter because it was a placebo, so it's all probabilistic. So it didn't matter what they chose, it's just the same probability overall. And the differences between these two algorithms is that instead of hard code set value, it's based on a sigmoid function, and as the player plays, and the differences between their HP, the HP of them and the player, it would be a value that would land on that graph and then be translated into the difficulty of the game. So those were the two. Then I have to build the questionnaires. One was the individual questionnaire, which was based on their experience right after playing that game. And the second one was a comparison questionnaire, which was at the end when they played both games and they had to compare, and they chose which one they preferred based on the questions. So first I had to collect participants. There were terms and conditions and details of the experiment in the survey. It was put in an information bulletin for my high school, and the two preliminary questions were on a 7-point scale of their experience with video games and their experience with 2D platform games. And the run-through of a trial, once I've collected all the participants, there were 10 participants. They would play one mode, and then they would do the questionnaire for that mode, and then they would play the second mode, and then do a questionnaire for that mode, and then finally do a comparison survey for those two modes. There were two trials ran, one where the static difficulty was played first, and the second trial where the dynamic difficulty was played first. And these are the results for the preliminary questions. So the mean average was 5.3 in terms of their previous experience with games, and the mean was 3.9 for their previous experience with 2D games. In terms of the actual game results, the blue indicates the win rate, and the graph is in proportions because the win rate was very high, and it's zoomed in so that the lose rate is more identifiable. And as you can see, the easy, medium, hard, the lose rates fluctuated, and the probabilistic was a bit higher. The lose rate was a bit higher than the easy rate. And as you can see on the bottom, there's the number of games that were played. Because probabilistic had easy, medium, hard, but they were all the same, there's more number of games compared to than with the other ones. And in terms of the questionnaire results, positive indicates higher responses of trial 1, and negative indicates higher responses in trial 2. So the questions were like sets of questions. So the first two questions, 1 and 2, were asking based on the challenge that they felt in the game. The 3 to 4 was based on the performance and the reflection of their performance. 5 to 6 was based on the time that they felt. 7 to 8 on the control that they felt, and 9 to 10 of their attention and experience overall. And lastly, the comparison results. 5 questions, and the first and the second, the static difficulty was larger, like more participants thought that it was easier early and middle game, but there was an equal amount of people that thought there was an easier late game for both modes. And actually, for the closest rounds, more participants thought the closest rounds was the dynamic one, and the preferred version, most of them indicated dynamic. So, in conclusion, to my research question, to what extent does dynamic difficulty vary from set difficulty in video games in terms of the link, if any, between player enjoyment and performance? And answer is relatively great extent. That's a comparison from that data. Now, for the limitations, so for the number of participants, of course, with more participants, there were 16 that replied, but only 10 showed up. So with more participants and more data, it's better to make a more accurate reflection of the population of people who actually do play video games. And another limitation is more levels implemented in the game. I found that people, because they were only easy, medium, hard, and you had to progress through those levels, and then once you unlocked all of them, you could try out. As you can see from that graph of the game results, more people there was double the amount of games that were played in hard than there were in easy and medium. So that means more levels that are implemented in that game would mean it would take them longer to play through that game, and you would see a more equal distribution of the amount of games that they would play. And lastly, the player data that wasn't saved, that was a limitation of the setup of the experiment in the computer lab, and restrictions based on the school computers that I could not save that data. So instead, I implemented the participants had a tracking sheet of their wins, losses, and the amount of games that they played. And that's my presentation on Adaptability.
Thank you. The first question for you, how did your initial exploration of the scholarly conversation lead to your final research question?
So the two papers that I mentioned, the methods that they used were similar because they wanted to find out, the two important parts were the qualitative and the quantitative, because you can't have one without the other in terms of video games, because it's the performance, but as well as the perception of the player of how well they're doing at the game.
How did the limitations of your method or data influence your new understanding?
So the limitation of my method or data helped me get a new understanding of how to set up an experiment. Because when I went to set up the experiment for the participants, there were issues with the computers that I could not save the player data, which was what I wanted to do initially. So I would say that I'd have to check before and test many times the setup and the surveys and all of the parts of my experiment that I want to give out to the participants.
Thinking back to the initial curiosity that sparked your inquiry, I guess all the way back to last year. What other curiosities do you have, and how has this process prepared you to explore them?
There was a chart before with all the different models of dynamic adjustment. So I initially wanted to do neural networks, but then I transitioned to probabilistic. So just getting a concept of each and every one of those models would be something that I would want to take a look at and pursue, and maybe compare the two different models and by which